Okay, after you have downloaded QMC zip file and unpacked it, you're going to see a folder that has these things in it. You need to scroll down to QMC2 and right mouse click on it. When you right mouse click on it, you're going to get a Properties tab, and you want to click on Compatibility and select XP Service Pack 3. The next step you're going to want to do is create a file that looks like this for your truth table. This is the name of the file. Inputs are W, X, Y, and Z. Okay, I should have a Z right there. Well, luckily it determined that it was a Z. I saved that file. Then to execute, you grab the file right here and you drag it down. You drag it down on top of the QMC. This is the only way to open it. QMC will bomb if it doesn't open this way. QMC is going to run really quickly, and it's going to give you a result. Down here I've circled it in red. But it's not using QMC, it's using CNS, another algorithm. But it is looking at the ones. So what we want to do is scroll down to the bottom here and click on Restart. And then once it restarts, click on One Set, QMC, and then you want to see all the details of the software, its internal workings. So you click on 4. And then once you've done that, then you can say Start. There'll be a Start button down here. And what I'm going to show you next is the result of that run where you click on Start. Okay, so the first thing QMC does is it repeats the input file. So that X is right here. This X means input. It's not the same thing as that X. And that X was translated into a Z. This Y right here means output. It has nothing to do with that Y right there. 48 literals. Well, a literal is one of these ones or zeros, and there's 16 of them. 16 times 4 gives you 64. But there's 1, 2, 3 that are don't cares. So if you take 64 and subtract 16 from it, you get 48. The Y literals, well, you start off with 16 of them right here, but 4 of them are don't cares, so 16 minus 4 is 12. So we're starting off with 10 mini-terms, where potentially there's a 1. The first one is 0011. So if we look up here, 0011 is a don't care. So it's including the don't cares in this. It says there's 10 of them. 10 don't cares are ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can just write them down. But we're not going to do that. What we're going to do is we're going to compare the 10 mini-terms, and we're going to start counting them. Remember now, these are inputs right here. So this mini-term has 2, this has 2, this has 2, this has 3, this has 2 ones, this has 3 ones, 2 ones, 3 ones, 3 ones, and 4 ones. Now we want to look at 1-bit changes. So we're going to compare this first one with all the 3s. This is a quick way, or a quicker way than I was doing in the class, of comparing them. So we're going to look for this one with 3 ones. Okay. So it looks like that bit right there is a don't care. So that's where the source of this dash is these right here that don't care. Now we're comparing it again with this one, and it looks like this first, the W bit is a don't care. So we're basically writing down here W bar X Y Z. That might be a better way to say it. And this one is what? X bar Y Z. And in a similar fashion, we could write down. So we're shrinking the number of literals. We're starting to circle all the implicates with 2 cells in them in the 4x4 Carnot map. Compare all the 3s with the 4. There's only one 4. So there's no further. So there's 14 intermittent implicants after the first step, right? So these are all the implicants that it's come up with. All of these guys. So it looks like there's 14 of them. Now it's listing off all 14 of them right here. And now what we want to do is again compare. So there's 2 here, there's 2 here, there's 2 here, there's 2 here, 2 here. So we want to compare all the 2s to the 3s. The 3s are where? Here's a 3, here's a 3, here's a 3, and here's a 3. So it's going to start off comparing all the 2s to the 3s. So that 2s compared to these 3s. Okay, it only makes sense to compare these when the current don't cares match up. So 0, we don't want to compare it with 10 because the don't cares there and it's not in the second position. 11 we do want to compare it with because the don't cares match up. 12 doesn't match up and 13 doesn't match up. So the only one we want to compare it to with is with 11. That's where these don't cares match up right here. So in a similar way we go through all of these. And you can see that 0 and 11 and 1 and 10 result in the same 4-cell implicant in our Carnot map. So we end up with basically 5 implicants circled, which is exactly what we saw in the previous video when we did this with the Carnot maps. So here what we're trying to do is we're trying to figure out which of these 5 are prime. And it looks like 9's prime and 12's prime. They're only covered by one of the 5 implicants. Here are the 5 implicants, and we're looking at how they're covering the outputs. That 1 in row 9, number 1 is well, we had them listed up here. Number 1's right here. So this would be X, Z. This would be the XZ implicant. So 1 is only covered by implicant 3, the XZ implicant. So that's most important to us. So what we're going to do is, okay, so that's covered, then we don't need these 2. Can we still cover everything? The answer is yes. So the question is, of the remaining of here, which ones do we need? And we're doing an analysis, and we're basically coming up with a solution of the 3 that we want. And it chose these 3 implicants. YZ, if you remember, was one of the optional ones. That's the way we're covering the don't cares. And there we're done.